All right, guys, welcome to the last math class of the week, obviously. It's been a whole week that we've been doing math together, and this is going to be for 7th grade, lesson 100. 20 more lessons to go before we actually finish the whole year. So I know that you know we are ahead. We are way ahead. We are so far ahead that if this continues for a couple more weeks, we might be done with a whole book before we actually get back to the physical building. That is crazy. But hey, I don't know what's going to happen. The Lord is the only one who knows, but that could happen. Now, the good thing is that today's lesson, even though it sounds really hard, it's actually not that hard. I promise you, it's not that hard. So let's actually talk about estimating square roots and irrational numbers. For the second part, the irrational numbers, I'm going to actually explain more than doing whatever the book says that we are supposed to be doing, because that doesn't really work. I don't necessarily like what the book does, because it doesn't really explain. So I'm going to give you some rule of thumbs and then tell you what irrational number is. But let's start with estimating square root. All right, so to estimate a square root, it's actually a lot easier than what you think. The first thing is that you know certain square roots already. Like, for example, if we do square root of 49, you know it's 7. And if we do a square root of 36, you guys know it's 6. So those you don't really have to estimate anything. It's those numbers in between 49 and 36 that we don't know what they are. Like, for example, what is square root of 40? So square root of 40 equals, we don't know. And to be quite honest with you, I have no idea off the top of my head what square root of 40 is. In fact, I would actually try to use a calculator or do something that we're going to show you later on how to do, maybe 8th grade, I think it is. Now we're going to show you a way in which we can actually simplify this to make it a little bit more obvious. But square root of 40 is not 40, okay? So one of the things that I want you to think about is the square root of 49 is 7. It's not even close to 49. And square root of 36 is 6, not even close to the actual number 36. Because a lot of people look at square root of 49 and they automatically think 49. No. It's 7. And square root of 36 is 6. So square root of 40 has to not be anywhere close to 40. It has to be closer to 6 or 7. In fact, if I drew a number line, and I had 5, 6, and 7, like this, I know that square root of 25 is 5, square root of 36 is 6, and the square root of 49 is 7. So where should square root of 40 be? Square root of 40 should be around here. It should be in between 6 and 7. It has to be in between 6 and 7. And so square root of 40, I think, is going to be somewhere around here. So all you have to do for this estimation part is not literally tell me, okay, I think 40 is going to be like 6.4 or 6.5 or anything like that. That makes it a lot harder. What you have to do is to say, I think square root of 40 is going to be between, so square root of 40 is going to be between 6 and 7. And that's it. That's all you have to do. That's how you actually know how you actually estimate square roots. And that's all you have to do for the first part of the lesson. So in the first example, they ask you, okay, so then can you tell us where square root of 200 is going to be? That is going to be quite easy if you know the following. If you know that square root of 196 is 14, and you should know this because I told you, please remember, please memorize them. You have to memorize them. And I went over the ones that you have to memorize, and you have to memorize your perfect squares from 1 to 16, and you also have to know 20, 25, and 30. So what I'm talking about is 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, 15 squared is 225, and 16 squared is 256. And you have to know those. So if you know those, then you know that square root of 196 is going to be 14, and square root of 225 is 15. If you know those, you know that. So you know that square root of 200 is going to be between 14 and 15. If you want to do the little number line that we did before, you can do it. I don't mind. I know I'm covering the camera, but just give me a second while I'm writing this down. So it's going to be square root of 196, square root of 225. And so we know that 200 is going to be closer here to 14, but we don't have to actually know if it's closer or not. All we need to know is that it's between 14 and 15. So square root of 200 is between, whoops, not how you spell between, is between 14 and 15. And that would be the first example. For the second part of the lesson, we're going to talk about rational numbers and irrational numbers. So I'm not going to go over the example because I don't think it's a very good example and I don't think it's relevant to what you need to know. But I will explain what the difference is between rational and irrational. So every single number that we've actually talked up until now, counting numbers, whole numbers, integers, and rational numbers, you know what they are. So what are they? They are counting numbers. So 1, 2, 3, 4, 5, 6, all the way to infinity, whole numbers, which are counting numbers and 0, and integers. Integers are going to be negative numbers and positive numbers that are quote unquote whole. So that means no fraction and no decimals. So those are integers. But what are rational numbers? Rational numbers are then fractions. Like, for example, 1/3 is going to be a rational number. And some of you might actually ask me, but wait, what happens if you actually put 1/3 into a decimal? I know it's going to be 0.3 bar, but because we can express it as 1/3, it's still going to be considered a rational number, okay? So that's a rational number. 1/3 is a rational number. Negative 0.5 is a rational number. 2 is a rational number. Negative 3/4 is a rational number. Negative 1 million is a rational number. So all of those numbers that we've done so far are rational numbers. So then you have a question, and the probably question that you have is, then what are irrational numbers? Irrational numbers are numbers like pi, okay? Not the food, but the number, pi. Why pi? Because pi actually never ends. Pi is not only 3.14, pi is like 3.1415926, and it keeps going and going and going and going and going, and it will never end. So pi, it's an irrational number because it never ends, okay? So that's one of them. What else is going to be an irrational number? Another irrational number is square root of 2, because we don't know what square root of 2 is. And if you actually put it on the calculator, it will actually tell you like the an estimate, but it won't tell you what it is. So square root of 2 is an irrational number. Also square root of 3, square root of 5, square root of 6, square root of 7. So you get the pattern, right? It's going to be everything that is not a perfect square. So notice I do not put square root of 1 because square root of 1 is 1 and 1 is a rational number. Square root of 4 because square root of 4 is 2 and 2 is a rational number. So anything that it is not a rational number would be an irrational number. So pi is the big example that we actually use for circles. And then now that we're talking about estimating square roots, we're going to do those square roots that we don't know about. Like, for example, square root of 200 is going to be an irrational number. Square root of 40 is going to be an irrational number. And that's why I think you have to take away from this. Not whether or not you can place them in a number line. That we can actually do, and I think we kind of did in the first part of the lesson. But in the second part of the lesson is that you have to understand pi is going to be an irrational number that is never going to end. And we know that pi starts with 3.1415 and so forth. So what you have to know about pi is that pi is between 3 and 4, because 3.14 is in between 3 and 4. Square root of 2, for example, square root of 2 is going to be in between 1 and 4. 1 and 2, I mean. 1 and 2. Why 1 and 2? Because square root of 1 is going to be 1. Square root of 2, we don't know. Square root of 3, we don't know. But square root of 4 is 2. So it's going to be between 1 and 4. Same thing with the square root of 3. Square root of 2 and square root of 3 are going to be between 1 and 2. So if we do a number line, between 1 and 2, square root of 1 goes here, square root of 4 goes here, so it makes sense that square root of 2 goes around here, and square root of 3 goes around here, but square root of 2 and square root of 3 are going to be between 1 and 2. I think this is about 1.3, and this is about 1.7. I can't remember. I think you have to know them for a couple of lessons in Math 8, but that's it. You don't really have to know anything more than that. And that's it. That's all there is to the lesson 100. I know it had a weird name, but that's all you needed to know. All right, so I'll see you next week with the next 5 lessons, and we'll see what